All right, today we are talking about chapter 3.2, which is all about the place value of decimals, okay? And your learning goal today is to be able to read and write decimals through the thousandths place. It's very similar to yesterday's learning goal, right? Yesterday's learning goal was to read, write, and model. Now you already know how to draw pictures to represent these, so we're just going to strengthen our understanding of how to read and write decimals through the thousandths place, okay? Let's take a look at this. It says the Brooklyn Battery Tunnel, that's a real tunnel in New York City, and it's 1.726 miles long. It is the longest underwater tunnel for vehicles in the United States. To understand this distance, to understand really how long that is, you need to understand the place value of each digit in 1.726. Okay, so the Brooklyn Battery Tunnel is a real tunnel in New York, and it goes under the East River, and cars can drive on it. And it's a way for cars to go underwater, right? Because the tunnel protects them from the water. Cool, right? So you will see up here, and I want you to write in your notebook this chart. It says tens, ones, tenths, hundredths, thousandths. What do we call this kind of a chart? What do we call this chart? Do you even know? A place value chart, because it's a chart that helps us organize our place values. So go ahead and set up this place value chart in your notebook. Now, where would we put the decimal point? Tens, ones, tenths, hundredths, thousandths. Where does the decimal point go? Daniel, where does the decimal point go? Right between the ones and the tenths, because that's the dividing line. Everything to the left of the decimal is greater than 1, and everything to the right of the decimal point is less than 1. Yeah. So let's look at this number, 1.726. In order to put every digit in the correct place in the place value chart, I like to start with the decimal point. So I know that the decimal points always need to line up on that same line. What numbers do I have to the left of the decimal point in my number? Shreya?
The numbers that are greater than,
Yeah, the numbers that are greater than 1. And in this example, talking about the Brooklyn Battery Tunnel, which digits are greater than 1?
the 1.
The 1.
Greater than 1
Is,
because it's to the left of the decimal.
I know that this one right here is to the left of the decimal point, which means that it is greater than 1. So does that belong in the tens place or the ones place? Tens place or the ones place, Matthew?
1.
1. Okay, so let's go ahead and write our 1 there. And then everything to the right, I can just write 1 in each place value column, right? So the 7 belongs in the tenths, the 2 belongs in the hundredths, and the 6 belongs in the thousandths. What is the value of the 2 in this number? What is the value of the 2, Yarden?
200.
2 hundredths. What is the value of the 7? What is the value of the 7, Marcus?
7 tenths.
7 tenths. And of course, what is the value of the 6? Misaki, what's the value of the 6? 6 thousandths. And what is the value of the 1? Zara?
1.
1 ones, or otherwise known as 1. Very good. So let's read this number so this is the number in standard form, right? So let's write that down, right? Standard form. Standard form is 1 decimal, or 1.726. S form, yeah, standard form, very good. The way you say a decimal number in word form is first you say everything to the left of the decimal, 1 in this case. The decimal is and, so you say 1 and then you read all the numbers to the right, 726. And then you name the last place value, which is thousandths. So in this case, the word form would be 1 and 726. And what's the last place value? Thousandths. Make sure you add the TH, right? Very good. Ariel.
Should I say like,
Yeah.
so 1 times 1,
Okay.
7 times 1/10.
Oh, before you go 7 times 1/10, though, what should we do to the 1 times 1?
Plus
We want to add them, right? Yeah. So 1 times 1 plus 7 times, oh, hold on 1 second.
1/10.
7 times 1/10. And you can write the 1/10 either as a fraction or as a decimal. We know both ways. And both are correct, right? Okay, very good. Plus?
Plus 2 times I think it's 1/100.
Yeah, times 100th. So you'll notice I wrote the 100th as a decimal, but the 1/10 as a fraction. Either one is the same because they equal the same thing, right? And Ariel, finish it up. What do we have at the end?
Times 1,000.
6 times 1,000. Very good. It says, a common garden spider spins a web with its silk that is about 0.003 millimeters thick. A commonly used sewing thread is about 0.3 millimeters thick. Okay, so which one's more thick? A common sewing thread or the spider's silk? Yeah, a common sewing thread. So it's asking, how does the thickness of the spider silk and the thread compare? Well, we know that the thread is thicker, but we want to be able to say exactly how much thicker. Okay, so step 1, I want you to write the numbers in a place value chart. So what's the first number? 0.003. How do I say that in word form? Rashika? Yeah, 0 and 3 thousandths. Let's write that in the place value chart. What's the second number that we're concerned with in this problem? What's the second number? Sarah?
Should I say it more?
Yeah.
0 and 300.
0 and 3 hundredths?
Oh, no, 0 and, wait, which number?
This one.
Oh. Wait, can you erase that? Because I can't see the decimal point as.
I'll tell you. It's like this.
Oh, 0 and
0 and 3 tenths. Yeah, so we've written both numbers in our place value chart now. 0 and 3 thousandths and also 0 and 3 tenths. And we want to compare how much bigger 3 tenths is compared to 3 thousandths. Okay? It says count the number of decimal place values to the digit 3 in 0.3 and 0.003. 3 tenths has how many fewer decimal places than 3 thousandths? Lots of you are showing me 2 with your hands. Okay, it has 2 fewer decimal places. So that means if I moved it over here, how many times smaller would it be? How many times smaller is it when I move one space to the right? Show me with your hands. How many times smaller? 10 times smaller. And then if I go another 10 times, it's 10 times 10, which is 100. So every time I move here, it's 10 times smaller. And here's another 10 times smaller. Yeah, very good. So two fewer decimal places equals 10 times 10, which is 100 times. So 3 tenths is how many times as much as 3 thousandths? Go ahead and say it. 100 times. And so another way to say that is 3 thousandths is how much of 3 tenths? 1/100th, yep. So the thread is how many times as thick as the garden spider's silk? 100. The thickness of the garden spider's silk is blank of the thread. What goes in the thread? What goes in the blank? 1/100th, yep. Okay. When we have a decimal point, we can add endless amounts of zeros to the right of the decimal point without changing the value of the number. Just like how we can add zeros to the left and not change the value either, right? Okay, so let's take a look at that. We can use place value patterns to name decimals in lots of different ways. We have the same number here, 0.3, 0.300, right? Are these 3 numbers the same? Yeah. Very good, right? These 3 numbers are the same. 0.3 is the same as 0.30, which has the same value as 0.300, right? So let's take a look at just the blue part. 0.3. In word form, that number is 3 tenths, right? In an expanded form, it's 3 times 1/10. What about here? What if we had an extra blue 0, 0.30? How many hundredths do we have? How many hundredths do we have? Rashika? 30. That's 30 hundredths. And how would I write 30 hundredths in expanded form? How would I write 30 hundredths in expanded form? Tanvi? 30 times 100. What if I have 2 zeros after the 3? 0.300. How many thousandths do I have here in blue? How many thousandths do I have? Neha? Yeah, 300 thousandths. And how would I write 300 thousandths in expanded form? Siddharth?
300 times 1 over 1,000.
Yeah, 300 times 1 over 1,000. So 3/10 has the same value as 30/100ths, has the same value as 300,000ths, right? Or sorry, 300,000ths. It would also be the same as if we kept going, right? We could keep adding zeros. So do you see how you can call a number several different names and not change the value?
Yeah. Go on with
Now, we could go on forever, couldn't we?
Yes.
Because of that, the convention, okay, the standard way of doing things is to not add any zeros at the end if we don't need to. Okay, so the normal way of naming this number in word form is 3/10. But if you wrote 30/100ths, would you be wrong?
No.
If you wrote 300,000ths, would you be wrong?
No.
It's all the same value, but the simplest way is 3/10. And we like things simple as possible, okay?